The CZ101 is the first of the Casio CZ series. It was released at the end of 1984 and was Casio's first semi-pro synth and the first ever fully programmable synth to retail at under $500. There's quite a lot of firsts. Casio produced around 68,500 of them. The concept of the CZ series was to produce an affordable synth that was programmable, had polyphony and could produce some sounds similar to an analog synth. But of course it has its own kind of unique thing going on. Casio realised that the sound of an analog filter and oscillators had become quite popular, sounds many musicians wanted to get their hands on, but a true polyphonic analog synth during the mid-80s carried a substantial price tag.
Do you agree to leave this place without your complete keyboard collection? Perhaps you could take a single Yamaha DX7 or the Moog synthesizer.
Yamaha had recently released the DX7, which was not exactly cheap, but not hugely expensive either, which was part of its initial appeal. They had licensed and developed FM synthesis, a form of digital synthesis which, rather than using vast analog circuitry, achieves all the synthesis digitally within a few custom microchips. Keeping component counts down obviously helps to save on manufacturing costs. Casio, potentially inspired by this, but couldn't use FM as that was Yamaha's thing, instead came up with phase distortion, which is kind of similar but not the same. Casio further wanted to draw upon some of the DX7's criticisms and make programming more intuitive and the sound more rounder and warmer and analogy. With FM synthesis, you have a number of sine wave oscillators, or operators as Yamaha call them. These operators are either carriers or modulators, so the output of one operator can in turn modulate the frequency of other operators, and they can be connected in different combinations known as algorithms. It's kind of like, if you're singing a note while somebody grabs his throat and shakes it at an audible frequency range. By individually varying the amplitude and pitch of each operator, with envelopes or LFOs, complex sounds can be generated, increasing or decreasing in harmonics. And the end result is quite unique compared to traditional analog subtractive synthesis. Although, for example, not impossible to mimic an approximation of an analog filter sweep, it's also not the easiest thing to achieve on a DX. Something that a Casio CZ can do a lot better. Anyway, we're talking about phase distortion here. So rather than modulating the frequency of one oscillator with another, the phase is modulated. In other words, the time domain of one waveform is stretched back and forth in relation to another waveform. A bit like grabbing a jelly that's in the shape of a waveform and wobbling it back and forth so its shape distorts. Another crap analogy. The CZ101 has what's called two lines, which can be mixed or ring modulated. Each line has an oscillator or DCO, a DCW, which stands for digitally controlled wave, which is the modulation source for the phase, and a DCA, digitally controlled amplifier, fairly self-explanatory. Each of these elements has an 8-stage envelope. For the DCO, this is pitch, DCW, amount or magnitude of modulation, and DCA, amplitude. The DCW can be thought of as like a filter in a traditional analog synth, and indeed some of the selectable waveforms are referred to as resonant, which when used can mimic the effect of a resonant filter. So just this part of the CZ synth alone, there's already quite a lot of complex sonic possibilities. Yamaha's FM and Casio's PD are similar in the sense that they both change the harmonic flavour of a sound by modulating one waveform with another. Other comparisons, they are both digital synths, which means most of the synthesis happens in the digital realm through algorithms implemented by bespoke microchips. Casio's background was mainly in producing LSIs, or large-scale integration. Essentially that is cramming thousands of transistors onto a microchip for bespoke computing purposes. So at the heart of the CZ synth is the Music LSI, a chip that does all the number crunching to figure out the resulting waveform, which then gets processed to analog by a converter. So I think it's about time to plug the rocker launcher in, take it for a spin, see how it sounds, starting on the first preset. Well, this is where we got to last episode. If you're familiar with your average Casio keyboard, they have presets, but there's little you can do to customise the sounds. But that's where the CZ is different, in being fully programmable, but it still has the presets. As you're about to hear, some of them are good, and some of them not so good. Trumpet. Lovely violin sound. This would probably sound nice for some effects on it, some chorus or something like that. Am I running out of polyphony there? keyboard's a bit dodgy. To be honest, I'd probably use this with a MIDI controller keyboard. Electric piano. Nice. Organ. Flute. Yep. So there's synth bass. Then if we press this button, you get another set of 8 presets. More brass. Vibraphone. Okay. Xylophone. Yeah. Strings. Synth strings. Funnily enough, I thought the acoustic strings patch on this sounded more synth strings than the synth strings. Sounds more kind of accordion-like. Fairy tale. Quite like that. Accordion or synth strings. Do you kind of like that? Sounds quite analogy. CS80, eat your heart out. Whistle. Oh, if only I knew how to play X-Files. Something like that, isn't it? Oh, this keyboard sucks. Don't know why I'm doing that. It doesn't have aftertouch or anything of that kind. This sounds like an old school computer game effect when the character is walking across a platform. What game is that? Yeah, the sound effect from Dig Dug. One of those kind of minor games. Going along, going down, up a bit. Yeah. What else we got here? So there's also another bunch of 16 presets in internal here. And these sounds are a little more interesting, I think. And we are back. So, internal presets. Interesting. I'm sure that sound did not sound like that a moment ago. It's quite DX7-y FM synthesis. Quite like that one. Another FM synthy sound. Cool. One for the dogs. Right, so that's all the presets. However, you can load in different patches, and there's some software as well that you can use to change parameters on the fly. So I'll show you that. One problem is, again, I couldn't actually get one of the main pieces of software to communicate with this. Okay, so let's start with this one. This piece of software is not free. It's called Patchbase. You can edit parameters in real time. I can't actually get this to work with my Casio. It just doesn't work for some reason, don't know. But yeah, you can see it's a nice user interface, a lot easier than poking away at buttons and menus and all that sort of stuff. But yeah, you can also use this as a patch librarian, so you can store your patches in here and transmit them over. And it also works with a range of other synths. Yeah, with the Casio, what it's doing is it's just sending system exclusive messages. It sends them in real time to the Casio so you can make changes on the fly. There's also this program. Again, similar kind of thing, just got your controls mapped out here. Again, I can't get this to work with the Casio. But anyway, this one's called Eddy Synth, or Eddy Syn. What I was able to get to work, good old SysX librarian. And so I've got a number of patches here that I've just downloaded off the internet. And this one actually works. We can demo some sounds. And you can just play them in to the Casio and it will start playing that patch. Shoot that one in. Or chapstick bass. Play that in. So yeah, true fact. True story, bro. If you're after a professional chapstick player, there's not many of them, and I think they all kind of know each other as well. Right, creature bass. Once you transmit one of these files over, it's just sort of held in memory, but it's not stored to a preset. So if you wanted to do that, you simply have to, press the right button, and then you get a message here saying write selected memory. So what you do is select internal and then hit patch that you want to store it to, and that should be done. So if I change patch, kind of nice. Anyway, back to creature bass. So, what else have we got? Digital noise organ. Let's give that a go. That does indeed sound like some kind of lo-fi 8-bit computer sound chip. All the squiggly noises on it, the digital artifacts. It's kind of cool. Drum bass. Let's give that a go. What else we got? Drunk trumpet. Fade pad. Fairy fly. So yeah, it's kind of capable of some fairly complex sounds. Funk wow bass. Hollow crystal. Robo growl. Cool. Rubber bass. Saxo bass. Snake pad. Interesting. Toad bass. So yeah, I think that sounds a good example of how you can achieve sort of resonant filter sweeps, or sounds that are like resonant filter sweeps, using a keyboard that doesn't have a low pass resonant filter. Not so easily achieved on a DX7. Whist pad. Yah after hit. Apple crisp. Forgotten. What's this? Let's try one more. Soft strings. Getting your head around the CZ is easier than a Yamaha DX. The layout is more intuitive, it's easier to program, and the guys that helped to develop it, I can't remember their names, and I probably pronounced it wrong, put it up on the screen now anyway. Anyway, they wanted it to have the feel and sound of an analog synth, but the end result is unique and it kind of holds its own. Okay, let's try and go over some of the controls, how stuff's laid out on the Casio CZ, how you can create sounds, how the sort of the architecture of the synth is made up, if you like. So starting over here, we have what Casio calls lines. So we've got line number 1 and line number 2. Line number 2 is literally just a duplicate of line number 1, and it's formed of 3 different sections. The DCO, or the oscillator. The oscillator has waveforms. So if we go to the LCD, you can see you can choose 2 different waveforms. So you've got first waveform and second waveform. When second waveform's on 0, it's just literally a repeat of whatever number 1 is doing. There are 8 waveforms that you can choose from. So we've got a sawtooth, a square, a pulse, don't really know what 4 and 5 are, more complex waveforms. And then these last 3 are resonant waveforms. First basically phase distorts the second waveform, or the other way around, I'm not entirely sure on that. But anyway, that is the oscillator section. Next to the oscillator we've got the DCW. What it actually is really is just sort of an envelope, and it's just kind of changing the amount of phase distortion that's happening between these 2 waveforms. You can basically use it like a filter. You can make the sound brighter or duller, you can make like filter sweeps, all that kind of stuff. Next to that we've got a DCA, or amplifier, pretty much like a VCA on any other synth out there. Over here we've got the line select, so you can hear just line number 1, or you can solo line number 2, or you can mix them, line number 1 going to line number 2, and you can use ring modulation on that, or you can modulate it with noise. 1 + 1, that simply means line number 1 is then duplicated by line number 2, and you can use this detune function to create a sort of detuned chorus effect between the 2 of them. The CZ only actually has 1 LFO on it, and that has 4 waveforms and is just routed to the master pitch, so you can create vibrato effects. Going back to these lines, each line has an 8-stage envelope, as you can see up here, so you can actually create quite complex envelope forms. But as well as that, you can actually make the envelope simpler. You could just turn it into a 4-stage envelope, like a traditional ADSR style envelope, just by moving the endpoint, and you can set the endpoint over here. And you can also change which stage of the envelope you want the sustain portion to happen. The envelope generator on the DCO, that changes the pitch. The envelope on the DCW, like I mentioned earlier, it changes that phase distortion amount between the 2 waveforms. And the envelope on the amplifier, that should be pretty obvious. So over here you've got value and cursor keys, and that's just your way of navigating through the different parameters. The cursor, you can obviously move the cursor back and forth and change the rate or the level. Over here we have portamento, so yeah, you can either turn the portamento on or off, and the time it takes to move between the 2 notes, and you've also got vibrato on and off. That's it. If you can get your head around that, it's all pretty straightforward to program. Every function has a dedicated key, it's all quite neatly laid out and sort of makes sense. For its time, this is pretty good. You know, you just select a function and use the cursor and value keys to alter its parameters. If I could get one of these patch editing programs to work, that'd be even better, really. You know, just using a mouse and a couple of clicks to completely shape an envelope is a lot easier than doing this, but you know, like I say, for the time, this is pretty good. Okay, so let's start by taking a listen to some of those basic waveforms. Just selected line number 1, so I'm really listening to line number 1. Use this initialize function down here. For any key you select, any function parameter you select, you can just put it to a default state. So I'm going to do that with the envelope on the DCW. Hold down initialize, press envelope. There we go. Kind of simple gate function on off. First wave, that's just a sawtooth. Square wave, pulse, I'm not entirely sure what that is, something more complicated. Half sine wave, and then we get into the resonant waveforms. Waveforms on the second waveform selection. So, what does that sound like? We've got a sawtooth and a square wave. And we got a sawtooth and a pulse. Now we're getting to the resonant waveforms, which currently don't really sound like anything because there's nothing happening on the envelope section of the DCW. So if we go back to that, select envelope. So anyway, on the first step we have a rate of 99 and a level of 99, so that's maximum level and fastest possible rate. So if we turn the rate all the way down to something like 24, that should be a slow rise in the envelope, a kind of a filter sweep sort of sound. And I play a key now. So now we can go over to line select, duplicated the first line, so we've got line 1 plus line 1. By default that should be detuned slightly. Kind of chorusy effect, and we can emphasize that a bit more, turn that up a bit, and let's make that envelope a bit faster. How does that sound? That's pretty cool. So as you can see, it's quite easy to get to some kind of normal analogy sounds. It's quite quick to dial something in. Okay, so what else can we do? We can ring modulate. Starts to sound a bit more kind of FM. Okay, so on the DCO you've got envelopes for the pitch, so what I can try and set up here, on DCO1, pitch going up, and DCO2, the pitch going down, so get something kind of like that THX sound. And dial in a slow rise in pitch. Okay, let's go with that, and let's go over to number 2, envelopes. So we want that to start at a high pitch, then want to move to the next step and have a slow return. So let's turn the rate right down on the next step. Yeah, that ain't working. Round about there. Okay, that sounds a bit more like it. Not exactly THX, is it? Kind of cool, all the same. Okay. Maybe put that down an octave. I think it's the best yet. Yeah, a little bit more fiddling around, I'm sure we'll get to a more genuine THX sound. So let's play around with the amplifier. Let's make it sustain or release forever. So end, this is the release phase. If I turn that rate all the way down, and let's do some detuning. Detune that a bit more. Too much. Yeah, it's kind of hard to play one-handed, really. try doing some drum sounds. It's a xylophone, so I think we can turn this into a snare drum by using noise modulation source. Adjust that release, so it's the release time, so it's much shorter. Turn that right up. There we go. Snare drum, instant snare drum. Drums typically also have a bit of a pitch bend on the attack. Kind of snare drummy. Okay, so how about a bass drum? Let's turn the noise off. And we just need to mess around with this pitch envelope a bit more, I think. It needs to go from high to low very quickly. So let's turn that. Then go to the next stage. And that needs to be really quick to go back to 0. The fundamental pitch is too kind of high, so let's turn that down. Just need a bit more sustain on that sound. Kick drum, bass drum. Is there anything this keyboard can't do? The Casio CZ101 is also 4-part multi-timbral. It can play 4 monophonic voices at once, but it can also receive program changes. I'm going to attempt to write something just using the CZ101. With just 4 monophonic tracks to play with, it's going to be quite limiting, but hopefully we can change patches a lot and very quickly to make up for this. For example, if I program a patch for a kick and another for a snare, and another for hi-hats, and then change those programs a lot within a bar, I can use just one voice to write some linear drum parts. Early computer sound chips had similar limitations and used similar techniques for game music. I can of course change patches on the other 3 parts too, have more instruments and sounds and textures within one arrangement. You can see on the top we've got hi-hats here, snare drum and a kick drum. You can see that none of these notes are actually happening at the same time. In drumming terms, that's called a linear groove, so you're not playing 2 things at the same time. So below that we can see the program change channel, and you can see that it's shifting programs within divisions of the bar. 33, this bass drum, 35, that's hi-hat, 34, snare, and so on. So it's changing quite rapidly within the bar. However, the Casio CZ wasn't really all that into that, and glitched out quite a bit. Having limitations can be fun and in some ways more creative. You're forced to think more about the core of the composition and what makes a tune good, other than just throwing every single possible sound at it and getting lost in endless possibilities. That said, the tune I've made here, well, I'll let you be the judge. The Casio had some very annoying issues and actually made things quite difficult and frustrating to work with. So the MIDI on this particular CZ101 is not great, as in it's very glitchy. For example, the MIDI out sends note on messages and not notes off, so it's pretty useless for playing stuff in and using it as a controller. It doesn't like receiving MIDI data on different channels at exactly the same time. You have to make sure notes aren't on top of each other. Also the same with program changes. All the events need to kind of be separated out, otherwise it just gets really confused. Notes also hang and you have to turn it off and reset it or change program, or take it out of the solo mode, or a combination of all of those things. So playing back a complete track can be a bit haphazard too. It glitches out in random places, and sometimes you get a MIDI data full message on the LCD. Sometimes it's fine if you just turn it off and leave it for a bit, and then plug it back in. It's all pretty random. I'd be curious to know if anyone else has had similar experiences with a Casio CZ. So the Casio CZ101 is actually a 4-part multi-timbral instrument. And to put it in that mode, you simply hit the solo button, and then when you press MIDI, you can assign 4 MIDI channels to 4 voices of your choice, and it also lets you add program changes. So you can see that it's we've got 2 parts here, and there's a program change happening every 4 bars. Okay, so that pattern's working all nice. Now if I add in the 4 to the floor kick, see what happens. starts cutting out some of the notes. And I think what's happening here is that if you send too many events, MIDI events, that are happening at exactly the same time, it can't handle it. Okay, so literally just shift this kick so it's not bang on the grid. Slightly off, just like real music and everything. Now if I play both those parts, they should play correctly.